Today, we're going to be talking about DNSSEC, or DNS security. You may have heard of this before, but you're wondering, why do I care? And what can I do with it? Once you understand that, you'll probably want to know how you get started. And we'll be covering all three of those things today. So let's first talk about why you need DNSSEC. Imagine that one of your users is trying to get to your website. Let's say IBM.com. They type in IBM.com in their browser, and it goes to their resolver, their DNS resolver. Their DNS resolver talks to the root zone. It talks to the TLD zone for .com, TLD for .com. And then it talks to the IBM.com name server. And it gets back an answer. But what can happen, what an attacker can do, is they can reroute traffic on the internet. It's not easy to do, but it has been done in the wild. And they can direct the resolver, instead of going to IBM.com, to go to the bad DNS server. The bad DNS server can then return, so it doesn't go here, instead it goes to the bad DNS server, can then return a bad IP address back to your user, and then they're sent to the bad website. At the bad website, their credentials can be harvested for malicious ends because their password is taken. Maybe you're a financial institution and someone can empty their bank accounts. Everything, bad things happen if you allow an attacker to insert a bad DNS server in the midst of the transaction, which sends the user to a malicious website. DNSSEC was created to prevent this type of thing from happening. DNSSEC does three things. First, it does origin authentication. Second, it implements data integrity checking. And third, it implements authenticated denial of existence. And we'll talk about what each of these things are in a little more depth as we go through this. So that's why you should care about DNSSEC and what DNSSEC can do for you. Now, let's get into some details about how DNSSEC works. So imagine your user again, up here. He's also looking for IBM.com. And he also talks to his resolver, goes out to the root zone, to the TLD authoritative server, and to the IBM.com server. But now we have DNSSEC enabled, so when he goes to there, it is validated. And so we validated that we're talking to the root server. So we've got the origin authentication, and we validate that the answer we got back is the correct answer. Then he talks to the TLD server, and same thing, validates he's talking to the correct server. So stopping the bad DNS server from being injected into the conversation, and he validates he gets the right answer back. And finally, we talk to the IBM.com server and validate that we get the correct answer back. That's a high-level explanation of how DNSSEC works and why you should care about it. The one thing I haven't talked about yet is authenticated denial of existence. So let me just mention that real quickly here. The idea of authenticated denial of existence is if I ask for a name that doesn't exist, let's say foo.ibm.com, and then I talk to the IBM.com name server, it's going to return to me an answer. It's going to say foo doesn't exist. I don't know what foo is. How do I know that foo really doesn't exist? And that's what authenticated denial of existence does. It's a method so that the resolver can validate that when the IBM.com server says foo doesn't exist, it really knows that foo doesn't exist, and it's able to put a check mark on that as well. So now let's dive a little bit deeper into how DNSSEC really works. There's one technology that undergirds all of DNSSEC, and that's public key cryptography system, PKCS. That's the idea that you can have a public-private key pair such that when you encrypt something with the private key, which you keep private, and publish the public key out on the internet or give it to other people, that when they decrypt the item with the public key, it validates that that the owner of the private key was the one that created that item. And it can be used for a number of functions. There's other videos you can watch that go into a lot more detail about PKCS. But essentially, it allows us to implement the origin authentication, data integrity, and authenticated denial of existence checks. Let's talk about exactly how that works. So there's a new record type that was introduced to DNS called the DNS key. The DNS key has two subtypes. One is called a KSK, and the other is called the ZSK. The ZSK, we'll talk about first, is used to sign the zone. That's why it's Z for zone signing key. And the way that works is if I have a record in the zone, let's say IBM.com is my record in my zone. It's got an IP address, say 9999.9991, let's say, is the IP address. Then I want to have a way to validate that this is really the correct answer or the right answer when it's returned back to the user. So we create this record type called an RRSIG, and it's a way to cryptographically sign or authenticate that this is the answer, that when this answer is returned, it really is the answer from this server, so the origin authentication, and it hasn't been changed. The RRSIG was created using the public key in the zone signing key. Now, then the question is, how do I know that this is really the public key of the IBM.com server? That's where the KSK comes in. The KSK is also a public key. It's used to sign the zone signing key. Then we get into the chain of trust. The KSK is known to belong to IBM.com because I've put what's called a DS record up at the TLD. The DS record stands for delegation signer. That is a hash of this KSK, so that when the resolver is going through the chain, going through its resolution chain, and it gets to the TLD level, it pulls down the delegation signer record. Then when it next goes to IBM.com level, it pulls a copy of the KSK and then compares the two. And if they match, then it knows that the KSK at the IBM.com level really does belong to IBM.com, and thus the whole, we've validated that we're talking to the correct server. The same thing happens at the next level up. The root has a DS record that points at the TLD. The same process occurs. The DS record is read, compared to the KSK at the TLD level, and then everything is validated. Up at the root, there's actually a file that is downloaded offline by the, when you set up a resolver, you download that file to start the chain of trust and validate that you're really talking to the legitimate root server. One more record type that was created for DNSSEC is called the NSEC record for Next Secure. The NSEC record is what's used for this authenticated denial of existence. It's the record type that's returned when the answer isn't known, and it validates that, yes, indeed, we don't have a record type named foo. So that's how DNSSEC works in detail. Those are all the new record types that you need to worry about. Now let's talk about how you can get started on your own to implement DNSSEC. The first thing you want to do is you want to sign the zone. What that means is you create all the new record types I mentioned here. You create a ZSK, you create a KSK, and then you create the RRSIGs. Depending on your software, the way you do this will be different. For some open source software, if you're running your own DNS, this will be a manual process. For some of the managed DNS services out there, you'll essentially flip a switch and all this will be done for you. Then, second step is you want to test. This is a really important point. I would highly recommend that before that after you set up all the keys, all the new records, that you test. There's a number of open source tools out on the internet and websites that you can go to that will validate that your DNSSEC is set up correctly and you have no errors. Test, make sure you get rid of all the errors. And then finally, you want to go to your registrar and set up the DS record. That's what actually enables DNSSEC. Up until this point, DNSSEC, all the records are there, but the resolvers are not actually validating the answers because they need the DS record to do that validation. So until you put that DS record in place, nothing's live. The system is just ready to go. As soon as you contact your registrar and put the DS record in place, the whole thing spins up, and now DNSSEC is in operation. And whenever a user goes to a validating resolver, DNSSEC will be checked, and it will prevent the scenario that we saw over here where a malicious player inserted a bad DNS server and redirected your server to a malicious site. So I hope you can get started on DNSSEC and protect your websites and applications. If you like this video and want to see more like it, please like and subscribe. If you have any questions or want to share your thoughts about this topic, please leave a comment below.